friend thinks that, or I think my friend might have a good talk. So I kind of rely on that to keep the speaker and content high quality, basically. So anyways, I've probably talked enough, and let's turn it over to Mike.
All right. Now, those who have not been to a Python meetup before, I am one of the few people that feel entirely comfortable giving a live coding demo while live streaming and somehow still not letting API keys get out. So, to build on last month at the meetup, the Backend Devs Meetup, the topic was effective microservices. And microservice, to some degree, can be described as anything that is not a monolith. Monoliths, think Django applications are actually pretty famous for being monoliths. My favorite example is all of Instagram, minus the mobile applications, is a single giant Django app in the back end. API, web front end, all of it. But what I would like to demo today is actually building a microservice architecture via serverless. There are a handful of ways to do this, not from scratch, and I can mention that after we have something built. But to just get started, to dive into this, when most people think of serverless, you're thinking of Lambdas or Azure Functions, anything where you give it a packet of code and you don't have to worry about the actual server. You don't have to spin up an EC2 or any kind of virtual server. You just say, here's the code. Whenever it gets a request or an event happens, just run the thing. I don't care. So just to get something off and running, we can go ahead and create a Lambda, just spit back some text at us. And I definitely went through earlier to make sure I did not have anything in here previously. So, for the purpose of the microservice, we can think of each Lambda as being an endpoint that someone would want to reach. So for a super boring naming convention, we can just call this an index endpoint. And I'm the Python guy, so it's Python Backend. And just giving it a basic service role so that we can send our statements over to logging. But very basic is our Lambda. And we're not going to read anything in. We're just dumping out just JSON, essentially. It's already built. It's great. If we want, we can go in and test it. Honestly, we can probably just leave it at that for now. Test up top, and that's what we get out of it. Very simple. You can so we have this. We have a basic Lambda, and we want to connect it out to the internet. We need a separate server or a separate service here called an API gateway. And this API gateway allows us to have an API front end, think RESTful API services, and connect it not only to Lambdas, but to anything else we could possibly want. You can even have it act as a pass-through service for third party. One of my favorite use cases is since you can deploy different versions, you can actually have versions where they are using a different version of your API gateway based on if they have a token, a user token or not. So if you have certain services that you want to provide, put behind a paywall, essentially, you can trigger. Not only do I not have to check that you have a token, but I can guarantee that you will never have access to these page features if you do not have a paid token. But just to keep on rolling, just going to create a brand new API from scratch. create API. So now we're in here. We can start building out all of our actual routing. But since we created that index from earlier, all we need to do is create a method on it. We can put a get in there, and selecting get, we just go in. Actually, it's just named index, so I can just call index there, save. And now our Lambda function that we created earlier is now our backend for this endpoint. And if we want to, we can also test with an example request body. If it will show up. Yep, there it is. Actually, we didn't give it anything, but that's what we told it to return. There it is. Simple enough. It's connected. Now that we have this API gateway, we need to actually make it publicly available. And we just go down to deploy API, create a new stage. You have to give it a stage name, so I'm just going to call it API. That essentially adds a top-level routing to it. So this URL that we have right here, you can hide this behind a redirect, however you want to take it, but that deployment or the stage name ends up being appended to the end. But I can copy this out, go to it, and there's our Lambda fulfilling us right there. Now, with all of that connected up, we can go in and create another Lambda. And for actually, now that we have something very basic, I would like to show one of the biggest advantages of using this style of serverless architecture, especially when you have a backend that is being shared amongst a wide variety of teams. And that is, because you are using Lambda functions as your backend, you can create a new function to say, instead of index, now let's just say it's people. So we would have on our API gateway, open up stage. Yeah, so instead of our root, we can come up here. Oh, that stage, resources, here we go. Actions, we can create a new resource. We'll call it people. So this is now /API/people. And let's say we want to make it a post. There we go. Now we have a post, and we need to build out our Lambda function. So let's say, going back, you have a team that uses Python, and they're in charge of, they're most comfortable using Python, and they're in charge of the home page. Let's say you go back into a different section of your API that's servicing these people objects, and that team is most comfortable working in Node. Well, because we are using functions, and functions are discrete, they don't interact with each other, you can set the language of this individual one to be a Node backend instead. So now you're divvying up your single API based on the language preferences of the team that is in charge of maintaining that particular endpoint or series of endpoints. So if we want, so now this is the Node version, is exactly the same down here. But what we can do here instead is just to add something and show off what this event object is here. We can just copy this down, JSON stringify the whatever payload that we're given, because this is designed to be a post handler. Stringify, and just get the event. Done. Save it, and configure this again. Just give it a different test just to show that it's going to work. You can test things individually. worked, and now we have this event. One of the nice things about using Amazon or the API gateway with a Lambda backend is if you've ever used Lambdas before, you have event and context objects that your functions are given in most cases. So if you have a Lambda that is triggered by, say, a CloudWatch event, like you're treating a Lambda like a cron job, it will be given information like what triggered it, the ID of the CloudWatch trigger, so you can handle different things. When you are using Lambdas and Lambda handlers as the actual execution layer of a serverless architecture, this event becomes exactly and no more than the payload of your body. Whenever your client makes a post request, put request, delete, whatever the body of that is, it gets sent in as the event, and then you can pull out any headers from the context, which we are not handling here. So now that we have this, and it's called people, we can go back into our API gateway, people, save it. Now that's there. I need to open up, I'm going to pull up Insomnia here, because I don't like using curl. All right, we need to grab this URL from earlier. Call that. Change it to a post, give it our URL, and add people to the end. Give it a JSON body. Getting my Python mixed in there. And just send it off. Now, from a day-to-day usage, you'll notice that we got this message, missing authentication token. And I wish that I had done this intentionally, even though I was going to get around to it. This is just how easy it is to forget a step. Whenever you change the actual structure of your API gateway, you need to come back and redeploy it so that your production version, staging and production versions are not instantly available. So now we can redeploy it, it's updated itself. And if I run this again, it will work. However, fingers crossed always. But this message, missing authentication token, is kind of a thorn in my side because this tells you nothing about what actually went wrong. If this were an actual error, this should be a 404 resource not found. But that's not what it gives you, and if this is the first time you're seeing this, or even if it's not, if it's the 100th time you just forget, it's really annoying to try to debug this. Anyway, reload, there we go. There's our payload embedded in our node fulfilled Lambda. And I can go out and I can talk more about the actual structures and build new things. We can embed more and more things into this, more in different, but it's all the same. One of the nice things about these Lambdas in this particular architecture, I'll do the pros first, is that because these Lambdas are all discrete objects, it makes testing really easy. You can test them all. You can test them all in your own time without having to go through the gateway. You can test Lambdas, just like we were doing here earlier with have a couple of example payloads, test, done. You can do that via whatever Amazon client library you're most familiar with, most comfortable with. And because these are Lambdas, if you're familiar with this whole thing up here, if I reload this, Lambdas have triggers and outputs, or things they're allowed to talk to. This was empty just before because we hadn't updated it. Now this Lambda is officially triggered by a request coming from the API gateway service. And then this over here is anytime we do a console or a print statement, it gets sent to logs, and we can come up here to monitoring and check all of those for debug purposes. But we can also add other things into here. Let's say we want to use this exact same Lambda to fulfill an Alexa skill, or the CloudWatch events, like using them as cron jobs. Imagine having a single Lambda that you have set on a cron job where it goes through and cleans up your S3 buckets once a day, or if I call this API, it will do it on command. So that's a good use case for this. There's what I mentioned before, where you can break up the fulfillment side into whatever language the team responsible for that component is most comfortable with. And the other great advantage is Lambdas, to some degree, are infinitely scalable. You don't if you get 1,000 requests in a minute and the previous minute there were none, there's no needing to spin up. Amazon handles that for you. You don't have to spin up an entire new server just for traffic that is on a single endpoint. And an aside to that one is you can actually go in and configure Lambdas to have different levels of resources behind them. So if you have a really high throughput or high computational Lambda, you can have all of your resources going towards that one Lambda that requires it, and then have almost no resources behind the other ones, either based on usage or what they require. So rather than having, say, a monolith or a series of Docker containers that you put and you need to scale up the entire cluster just to handle one really intense endpoint, you can just scale up a single individual Lambda. Now, the downside, because there's always a downside when it comes to microservices. Because all of these are discrete, that is where a lot of the problems come into play. Packaging and deployment can be done in CI, but there's a lot of code copying. If you have a shared set of libraries, like a lot of applications that we build have the good old util file with all the things that all of your other resources call or just are useful. Or you open a single database connection that all of your views share. That becomes harder. Not necessarily that it is more code to maintain, but because all of these Lambdas are discrete units, all those files need to be packaged together individually for each time you need to redeploy the core logic of your Lambda function. And then on top of that, if you don't have continuous integration set up with these, making sure that if I made say a bug fix in my util file or any of my shared components, I now need to make sure that all of the Lambdas that use it are then upgraded. These are things that you can do in CI, like Travis or GitHub integrations. But if you don't integrate that early on, it can very quickly come back to haunt you. Another thing is Lambdas that are not used do get taken off of servers. Just because, people will tell you this, just because the name is serverless does not mean it's not running on a server somewhere. It's running somewhere, but if it's not used, your code is not loaded in production. When you have a seldomly used Lambda that now gets a call, it needs to first be loaded onto Amazon or Microsoft servers. Once it's ready, it can then go in and fulfill the request. But because it needs to load in, your startup time is essentially for that request. So whatever user is waiting to get information back, they're waiting for your, essentially, a microservice application to boot up. So if you're using some hefty libraries with a long startup time, you might want to keep those particular instances on a traditional server. The other downside to this, and not necessarily a downside, but something that you're not going to think about until people start complaining, is on the API gateway side. API gateway has a limitation on it which is the number of requests that it is set up to handle per second. This is supposed to be so that you don't get DDoS attacks or anything malicious coming at your site, and therefore Amazon. But if your service gets really popular, and I think the default is 250 requests a second. Once it hits that, it starts refusing connections. But it doesn't notify you of that. And you actually need, I think at this point, you need to contact Amazon support to increase that, because there's no way of doing it just in the console. And there's another caveat on this, is that is not per API gateway. That limit is applied in aggregate across all API gateways associated with your individual account. Now, for an individual, personally, as one of my personal projects, I have one that gets 130 requests a second. I'm not going to hit that anytime soon. However, I work for Disney. Disney, an enterprise at that scale, is going to hit that very quickly. No matter how many environments that we have, I think we have over 100 different AWS environments at Disney across the entire company, and that's probably a very low conservative number. But when I was creating this style architecture at work for a project, it was a high network throughput, and we needed to test it. We needed to load test it. And for load testing it, we discovered that, not only did we hit up against the 800 requests per second limit on just this one environment, or just this one application, we're now providing what is essentially a DDoS attack against all of the other projects at Disney in this environment that are using an API gateway. So unintended consequences. And so yes, by the way, we are using, just my team in Disney is using the type of architecture for some pilots right now, and it's working very well in production with those caveats in mind. So it does work. Fingers crossed for another 2 months, at least in my case. But it might not work for you. It might work for you. I guarantee you this is cheaper, or in most cases, this is going to be cheaper than trying to have a regular set of servers that can handle the same number of requests. But that should be handled on a case-by-case basis, because while the cost per unit of an API gateway call is very low, even with a really high number of requests, it's maybe $1 a month. The routing is essentially really low. Lambdas are based on execution time, and if the default timeout is 3 seconds on Lambdas, we have something that can take up to 15 seconds before it times out. But you are being paid on 200 millisecond increments with a minimum payment of 100 milliseconds. So if you have something that takes a really long time, Lambdas, this particular architecture is probably not the way to go either.
Sort of encourages you to make sure everything takes 1 second.
Pretty much. Yeah, if time management.
From Dollar's perspective, there's no difference between 300 milliseconds.
Yeah. On a traditional server system, the execution time is not what you're paying for. You're just paying for a server that's sitting there. So it's more of a static cost over the course of the month. Now, this was a really quick way of getting something set up for demo purposes. And if you're building something out solely, if you're starting with this, it's really easy to get going with it, as long as you introduce CI tools into the mix. Otherwise, you're going to lose your sanity when you get up to something like 100 endpoints and you need to redeploy a whole bunch of times. But if you have an existing application, there are a handful of tools that exist that will take your existing monolith or microservice and convert it into this exact type of either AWS, Google, or Microsoft-backed serverless architecture with Lambdas, functions, whatever we have it. I only really know in the Python space, again, Python Meetup guy, there's a tool called Zappa, which Zappa, which is specifically designed to convert Bottle, Flask, and Django libraries, and maybe a couple more that I'm forgetting. You build out your Flask app, or so as an example, you have a Flask application with a handful of views, your database connection, what have you. You build it out locally on your machine. You make sure everything works, and instead of pushing out your finished server, you do Zappa update in whatever the root directory is. It then goes through packages, processes your entire application, and deploys it up to the style of serverless architecture, no other input on your part. So there are tools like this that exist. But if this looks interesting, or if you have, again, my favorite use case for this, and why we actually ended up using it in the first place, is having various teams use whatever tools they are most comfortable with, provided that they are comfortable putting in a Lambda. That is my single best use case for this type of architecture as it is implemented here. So, other than the very start of this talk, went over with no hiccups. Yay. Any questions before we go on?
What are the current recommendations for how you should handle something like database connectivity? Like, we're a package of Flask and put it in. How should you deal with database access?
Mm-hmm. So, because the lambdas are discrete, each lambda that requires a database connection is going to have to maintain a database connection. Now, just because you need to connect to a database doesn't mean that you need to reconnect to the database every single time that your lambda is called. When I talked about the startup time, the startup time is when it's been off the server. When it needs to get put back onto the server, it will run through all of your globals and instantiate them. So if you want but then all of those globals remain in memory as long as your Lambda is loaded on the server. So you can load your database connection or any other remote connections that you need as a global variable, and those will persist between the individual calls to your Lambda until it gets unloaded. So in this case, that startup time, all of your connections are going to be paid by the first user to call that Lambda since it's been loaded. But once it's already loaded, it goes lightning fast because it doesn't need to reconnect every single time. The other thing is that if you're calling a Lambda that doesn't require a database connection, you don't need to include a database connection in that Lambda.
You mentioned it doesn't tell you, the API gateway doesn't tell you if you're blocking your requests. Are you able to set up some sort of CloudWatch logs or anything? Is there any recourse for that?
Well, that's how I figured out where it was, a mix of CloudWatch logs and some creative Googling. I figured out what was going on the 5th page of Google, which either tells me that not a lot of people run into this problem, which also is probably why they don't have a way to do it without contacting support, or I'm just really bad at Googling. I don't think anyone in this room makes a living as a developer and is not good at Googling.
You were mentioning about database connections. Does it kind of, if you have pooled connections, is it going to honor those and persist them as it moves the Lambda throughout? As it uses more resources?
Well,
Any experience with that?
since with Lambdas, it's my understanding that you don't need to have pooled connections because the Lambdas are discrete. There's only one Lambda at a time that's ever going to connect to it. I could be wrong. It could be that your Lambda gets so popular that you need to have a database connection because this Lambda handler back in here, let me get into here. let's just say our database is just that. It's a global variable, whatever. Once this is in memory, actually, that could be it. If you might actually need to up to a pooled connection if your Lambda is so trafficked that whatever Amazon's backend system, it's not loading in new instances of the Lambda to handle the load. I think AWS is good enough where it will that loading that first time from you put it in there as a cold start essentially. But once it gets over a certain number of requests over a given time frame, I think it will load up now 2 instances or 3 instances of this Lambda, and each of those would have their own connection. But seeing as that one Lambda, this function just gets called as many times as possible, and even in here, it's an asynchronous function, so that Lambda can be called as many times as it wants on that particular thread. So it might. I haven't used this at a high enough scale where I've needed it, so I can't give a definitive answer on that.
Oh, that's great, thanks.
If you suddenly say get a lot of publicity from what you're doing, somebody interviews you or something like that, so it gets hit all of a sudden with a whole bunch of requests. Do you have a way to respond to that really quickly?
Well, it's not the only thing that you would need to worry about in terms of the sheer number of requests that you're getting is making sure that your API gateway is able to, or is configured to handle, or not even configured, is authorized to handle enough requests per second. If you are anticipating a high load, it wouldn't hurt to contact support to get that limit increased. But we can't predict popularity of particular services until something happens. So, and it's not like they're going to say no, because there's the potential that you're just going to give them more money because higher throughput, but they just have it set at an arbitrary level, and that's it. I don't think they would ever give you a reason to say no. No, we're not going to allow you to give us more money.
About resource discovery, I've got a couple of little serverless functions I run just for fun stuff. But I don't have a great way of showing people or telling people in one spot, hey, here's what's available, here's some documentation about basically updating quickly. And that's something I kind of miss from having a Swagger API that I can just kind of generate docs for.
Mm-hmm.
I was wondering if you've seen anything or maybe what you use at work to kind of express to people what you have available.
Well, if you, in that case, because your API gateway and your Lambdas, they're just like any other resource on Amazon. The Python library Boto 3 that they release, you can query what are all the different Lambdas that I have. Let me match the ARNs together and then generate your documentation or whatever static site generator based on the current state of the resources that you have deployed in AWS. Yeah, and the API gateway and even all of these Lambdas have fields for descriptions and not only environment variables but also tags. So you can, if you wanted to, you could say tag my different API parameters, and then the value is the description of that API parameter. Just spitballing.
Nice.
You mentioned that there's some latency when it spins up. I mean, is it sub-second? Things that are very time sensitive. Is it a couple hundred milliseconds? Is it 3 seconds? Or?
It's variable. The easiest way to make sure that it is short is to make sure that when you are testing locally on your computer that it starts up quickly. But it's hard to get a definitive answer on how long it will take. It's usually, in my experience, it's under 2 seconds. I think 2 seconds is the longest we've ever had to wait for it to actually start up. But it's usually much shorter than that. And it's entirely based on whatever Amazon's internal load is at that particular moment.
And do you have a feel for if you don't use it for 2 days or an hour or kind of?
It's also subject to whatever their load is. I believe there is a minimum amount of time that they will guarantee that your Lambda is up. But as to the average amount of time, if they're really, if the server's having a slow day, it will be on longer. You're not being charged because it's execution time. It's based on execution time, not the time that's loaded on the server. But if it's really busy and you haven't had a request in whatever that after that minimum guaranteed uptime, yeah, it's going to be taken off.
One more question. One quick one. So if you get flooded with 200 requests within that first second, how many instances of that function are actually going to be instantiated? Let's say that they don't return for 5 seconds each. Is the answer 200 or 1? It seems like there's an information here.
I would actually be really interested in talking with an AWS engineer about that because well,
Does it have to be re-entered? If you don't have to be re-entered, then I would think that AWS is tracking each call, and until it returns, it's not available for the next call, right?
yeah, it would be in a queue, and let's say one potential way is the queue is under a certain length, and that first one it's spinning up the instance of this Lambda, and then okay, fine, we can just run them all through. But maybe it gets over a certain threshold, like there's 200 in the queue, and if there's over 150, start up another one. Now you have 2 that are responding in parallel, and let's say you just don't get any more, they'll both be shut down.
We don't know. AWS mandates.
Yeah, this is the whole thing of serverless. How does it do? I don't know.
All right. Well, that was.
No.
Okay.
No, I'm so used to giving talks at the Python meetup, sitting at a round table with everyone. This whole mystical golf thing going on with this podium is very interesting.
All right.
Well, we'll take a quick 5 or 10 minute break. There are bathrooms in that general direction. You should be able to find them.